Hello there. Our topic for today is sensory nerve conduction velocity studies. The basic difference between sensory conduction velocity and motor nerve conduction velocity is that for motor nerves we examined the motor nerve and we recorded the potential that the particular motor nerve supplied. But the difference here is for sensory nerve action potential or sensory nerve conduction velocity studies, we examine the nerve itself rather than the muscle. Okay, therefore the sensory nerve action potentials are of much smaller amplitude than that of motor nerve action potentials. These are the parameters for which we examine the sensory nerve. Most of the sensory nerve responses are very small, ranging from 1 to 50 mu volt. The sensitivity is 10 to 20 per division. The sweep speed is 20 milliseconds. The electrical pulse is 100 or 200 microseconds. The amplitude of stimulation ranges from 5 to 30 milliampere. Always remember that the sensory fibers have a quite less threshold. That means that they get easily stimulated than that of the motor fibers. Moving on to the electrode placement. As you can see here, the electrodes G1 and G2 are placed in the line over the nerve. This is where G1 and G2 are placed, right? The distance, the inter-electrode distance should be 2.5 to 4 centimeter. The active electrode, this is the stimulator, right? So this is the active electrode which is placed close to the stimulating electrode. Specifically for sensory nerve conduction velocity, you can see here we use this special type of ring electrodes. Now, sensory nerve conduction velocity studies records a compound potentials, right, that represent the summation of all the individual sensory nerve fibers. This can be either biphasic or triphasic. As we did in motor nerve conduction velocity, the parameters or characteristics of measurements remains the same. That is, the onset latency, the peak latency, duration and amplitude are measured. Now, moving on, the first parameter is onset latency. Onset latency is the time duration from stimulus artifact to the first deflection. As you can see, the stimulus artifact here. This is the onset, the blank line you see here. It is the time duration in milliseconds, right, from the stimulus artifact to the first deflection from the baseline. This onset latency represents the nerve conduction time from the site of stimulation to the recording electrode. That is, from this site of stimulation to the when the impulse moves from this site of stimulation to the recording electrode, this is termed as the onset latency. The stimulation site to the recording electrode, and specifically for largest cutaneous sensory nerve fibers. The second parameter here is the peak latency. See, this is the peak latency. Peak latency, as you can see here, the peak latency is the midpoint of the first negative deflection or the first negative peak. The duration is measured from the onset to the first baseline. You can see here, this represents the duration from the onset of the potential to coming back of the potential to the baseline. This is termed as the duration of sensory nerve action potential. Then we have the amplitude. The amplitude is basically measured from the baseline to the negative peak, as this represents the amplitude from the baseline to the negative peak. Then we have sensory nerve conduction velocity. Sensory conduction velocity represents the speed of the fastest conducting myelinated nerve fibers. This can be measured by providing just one stimulation and dividing the distance traveled by the onset latency. So the distance is divided by the onset latency. This gives us the sensory nerve conduction velocity. Then for sensory nerve method of stimulation, we have two methods of stimulation. The first is orthodromic. Okay, as we have discussed earlier, orthodromic method of stimulation is particularly in the physiological direction of stimulation. The stimulating electrode is placed over the distal sensory branches. As you can see, this is where the stimulation is provided, and it is recorded to the proximal point over the nerve trunk. Point over the nerve trunk. The impulse is conducted orthodromically, that is the normal physiological direction of the sensory nerves, traveling from distal to proximal. The another method of stimulation is antidromic stimulation. It is in the direction opposite of that of stimulation. We provide stimulation proximally and record the potentials distally. This is in the direction opposite to the physiological direction of sensory nerve conduction. Therefore, it is known as antidromic method of stimulation. This was all about sensory nerve conduction velocity studies. Thank you.